Hi guys, today we're going to do section 8.3, but before we get to that section, I wanted to do a quick review of simplifying radicals. We're going to start with multiplying two radicals. In this case, if we multiply root 2 times root 3, we just get root 6. It's as simple as that, multiplying what's underneath the square root sign. So in this case, we get square root of 9. However, this can be simplified to just plain old 3. So you'll see when you multiply two radicals that are identical, what happens is those square roots ended up canceling each other out, and you just get that number that's under the root. The next one is just going to be square root 15. So again, when you multiply radicals, you just multiply the numbers that are under those radicals. So here we have a little different situation. Here we have a radical on the bottom of a fraction in the denominator, and that is not considered to be simplified. So you have to do a thing called rationalize the denominator. And the way that you do that is you multiply the top and bottom, the numerator and the denominator, by whatever's on the bottom of the fraction. So in this case, root 3 is on the bottom, so we're going to multiply top and bottom by root 3. In the numerator, we now have 2 root 3. In the denominator, we have square root of 9, which we all know is 2 root 3 over 3. And so that would be our final simplified answer. Number 5, square root of 16 is actually a nice number. 16 is a perfect square, so this just ends up being 3/4. And here, square root of 2 is not a nice number, so we have to rationalize the denominator. We're going to multiply top and bottom by square root of 2 this time, because that's what's on the bottom of this fraction. And so we're going to wind up with 2 square root 2 over square root 4. But the square root of 4 is 2. But then look what happens here. We have 2 over 2 that can cancel. And so then we just wind up with our answer, square root of 2. If you want to think of it as square root of 2 over 1, that's fine. This will come into play in today's lesson a little bit. So to start section 8.3, today we're going to be studying two very special right triangles. We're going to be studying the 45-45-90 triangle, which has corners or angles that are 45 degrees, 45 degrees, and 90 degrees. We're also going to be studying the 30-60-90 triangle that has angles of 30 degrees, 60 degrees, 90 degrees. These two triangles are called special right triangles because they show up all the time in math. From here on out, from geometry and beyond, you're going to run into these triangles a lot. So to show you how the 45-45-90 triangle works, I'm going to demonstrate with a square. Now, what do you know about a square? You know all the sides are the same length. So if one side is x, all sides are x. You also know that the corners have 90-degree angles. And one of the things that you learned in Geometry A is that the diagonal of a square will bisect the corner. And so this ends up being 45 degrees and 45 degrees because that 90 degrees is cut in half. And same thing down here. And then this corner is 90 degrees. So you can see we now have two triangles that if you put them together make the square. And the triangles are each 45, 90 degree angles. So what if I wanted to find the length of the diagonal of this square? I think I could do Pythagorean Theorem. So let's call this diagonal D. And so since I have a 90-degree triangle, a right triangle, I'm going to do x squared plus x squared equals d squared. D has to be the hypotenuse there because it's across from the 90-degree angle. It's our longest side. So when I do Pythagorean Theorem, that goes in for the c squared spot. If I have x squared plus x squared, that's really 2x squared. And then if I wanted to simplify this and try to find the diagonal, the length of the diagonal, I would have to take the square root so that I would wind up with just plain old d. Well, the square root of 2 is not a very nice number, so I'm just going to leave that under the radical sign. The square root of x squared is x. And so what happens is the length of the diagonal is x root 2. Now the cool thing about this is, let's say I have a square and I know all the sides are 5 and I want to find the length of the diagonal. Well, the length of the diagonal is just going to be 5 times root 2. Or let's say I have a square and the sides are all 7 and I want to figure out what's the length of the diagonal. I now know a shortcut. It's going to be 7 times root 2. If I wanted to leave it like that, it's considered simplified, but if I wanted to type it in and get a decimal, I could do that too. So what we've just figured out is that in a 45, 45, 90 triangle, two legs will be the same. Why is that? Because this angle has to be 45 degrees in order for the triangle to have a sum of 180. And if you have two angles that are the same, the two sides opposite of them will also be the same. And then what we just learned is the diagonal will be that number times root 2. And that happens in every single 45, 45, 90 triangle. So if you're given the legs of a 45, 45, 90, and you want to find the hypotenuse, all you have to do is multiply by the square root of 2. And you'll get the hypotenuse or the diagonal. If you're given the hypotenuse, then you're going to have to work backwards to try to find one of the legs. And so in this case, to work backwards, instead of multiplying, we're going to divide. So if you're given the hypotenuse, you're going to divide that number. Whoops, if I could spell, that would be great. You're going to divide your number by root 2. So again, if you're given the hypotenuse, to work backwards, you divide by root 2 and you'll get the length of a leg. So let's try one of these. In this triangle, part A, we can see we have two legs that are x and x, which means they are congruent to each other. Now, if two sides are congruent, that means two angles are congruent. This is an isosceles triangle. The angles in every triangle have to add up to 180. So 180, take away the one corner that we know, the 90-degree corner, it leaves us with 90. And if we divide that in half, we get 45. So what we've just figured out is this corner is 45 and this corner is 45. We have a 45, 45, 90 triangle. So let's solve for x. We're going to solve for it in two ways. The first way is an approximate answer. Now, if we have the hypotenuse, we're going to have to work backwards by dividing by root 2. So what I could do right now is just take my calculator and type in 12 divided by root 2. And I get approximately 8.49. That is one of our answers. That's the approximate answer, the approximate length for x. But let's say I want an exact answer that's not rounded off. And so again, in order to find x, it's just 12 divided by root 2 if we're working backwards to find a leg. Now, think of what we learned at the beginning of the lesson. We learned that you can't leave a radical on the bottom of a fraction. So we multiply top and bottom by square root of 2. On the top, we get 12 root 2. On the bottom, we get root 2 times root 2, which is root 4, but the square root of 4 is really just 2. 12 divided by 2 is 6, so our final answer, x also equals 6 root 2. So we have an approximate answer and an exact answer. Okay, let's try another one. Here we have a 45, 45, 90 triangle. I know this corner has to be 45 degrees because it has to add up to 180. And so this time I'm given a leg. A leg is 4, and I have to find a hypotenuse. So we know we're going to take 4, multiply by root 2. Is this a simplified answer? Technically it is. It is an exact answer, but I can also get the rounded answer, which is going to be 4 times the square root of 2 into my calculator, which is 5.66. So again, we have the exact answer and the rounded answer. All right, let's try one more of these. Again, I see the two sides are congruent because they're both length x, which means that the two corners have to be 45 degrees and 45 degrees. I'm going to have to work backwards. We're given the hypotenuse. So in order to do that, we're going to take 5 root 2 divided by root 2. When we work backwards, we divide. This one's really cool because something nice happens. They cancel, and we are left with just plain old 5. Guess what? That is the exact answer and the rounded answer. There's only one answer in this case. Now we're going to talk about the second special right triangle. This is called the 30, 60, 90 triangle. And so if you imagine this being an equilateral triangle, meaning all 3 sides are congruent, and we want to try to find the height of this triangle. The height would start here at a vertex and come down and be perpendicular to the base. Now, one thing we know about a equilateral triangle is that if it's equilateral, it's also equiangular, which means if we take 180 and divide it by 3, all the vertices have to be 60 degrees. And this vertex at the top would get split into 30 and 30. And so you can see if we take half of this large triangle, we have a 30, 60, 90 triangle. Now, if we drop down that altitude or that height, this distance down here and this distance over here will be the same. They will be congruent. And so this whole side would be called 2x if each of these smaller parts are x. Since it's an equilateral triangle, we could also say this is 2x and this side is 2x because it's equilateral. So think about trying to find the height. Let's call it h, and let's do the Pythagorean theorem. So we can take x squared plus h squared equals 2x squared. If we just think about the Pythagorean theorem and taking half of this triangle, the 90-degree angle, the 30, 60, 90 triangle. Now there's not much we can do with x squared. There's not much we can do with h squared. But we can do something with the 2x squared. 2 squared is 4, and x squared is x squared. Now notice we have some like terms. I can get my x squareds together. So if I subtract x squared from both sides, I'm going to be left with h squared on the left. Now 4x squared minus 1x squared will be 3x squared. And again, I'm trying to solve for the height, so I want to get h by itself. So I'll take the square root, and the height would then be, the square root of 3 is not a nice number, so we'll just leave that under there. But the square root of x squared is x. So the height of this triangle would be x root 3. Now here's what we just figured out. Take a close look at the 30, 60, 90 triangle. So this is 30, this is 60, this is 90. What we have is this side is x. The hypotenuse is double, or 2x, and what we just figured out is the height would be x times root 3. And this is true for all 30, 60, 90 triangles. They will all have that same ratio. So here's what we know. The smallest angle is opposite of the shortest leg. So this over here would be called the short leg. And let's just say the short leg is x. If the short leg is x, the hypotenuse, which is across from the 90-degree corner, has to be double the short leg. So we'll call that 2x. And then this side over here, which would be across from the 60-degree angle, this side over here, would be called the long leg. And that would be x times root 3, kind of like the height of that equilateral triangle. So let's talk through this. If you're given a short leg, how do you find the hypotenuse? You multiply by 2. Hypotenuse is double the short leg in a 30, 60, 90 triangle. What if you're given the short leg? How do you find the long leg? Well, then you multiply by square root 3. If you're given the hypotenuse, you're going to have to work backwards to find the long leg. So this is kind of interesting. What I would do is, if you don't know the short leg, get that first. So if you're given the hypotenuse, first divide by 2, and then take that short leg distance and multiply by root 3. So it's going to be sort of a two-step process to go from hypotenuse to long leg. Divide by 2, then multiply by root 3. If you're given the long leg, how do you work backwards and get the short leg? Well, working backwards, you're going to have to divide. Oops. So if you have the long leg, you're going to divide by root 3 to get the short leg. If you have the hypotenuse, how do you work backwards and get the short leg? You're going to have to divide it in half, or divide by 2 to get the short leg. And then finally, what if you had the long leg and you had to work around to get the hypotenuse? Again, it's going to be a two-step process. So start out by dividing by root 3, and then that will give you the short leg. Once you have the short leg, then multiply by 2. It's a lot to remember, but I think as you practice it, you'll get better at it. So here you can see we have a 30, 60, 90 triangle. The hypotenuse is y. The short leg is across from the 30, so the short leg is over here, x, and then that means 12 is the long leg. Now, rule of thumb is if you don't know the short leg, find that first. So we're going to try to solve this for x and y. So let's solve for x first. So if we know the long leg and we want to work backwards and find the short leg, think about your 30, 60, 90 triangle. The short leg, if that's x, the long leg is x times root 3, and the hypotenuse is double whatever the short leg is. So what I would do is I would take that long leg, that 12, and divide it by root 3 to work backwards. You're going to take this and you're going to divide it by root 3 to get rid of that root 3 so that you can just have plain x. Now, a couple of things. One is we could type this directly into our calculator right now and get an approximate answer, which would be 6.93 if I type that into my calculator. Or we can take 12 divided by root 3 and get an exact answer, which we have to rationalize the denominator. So we're going to multiply top and bottom by square root 3. On top, we get 12 root 3. On bottom, we get root 9, which is also 3. 12 divided by 3 is 4. So 6.93 and 4 root 3 are the approximate and the exact answers for x. All right, now we're going to find y. So once we know x, to find y, we just double our answer. So if we have 6.93 times 2, we can get an approximate answer for y. That will be about 13.86. Or we can get an exact answer. So we can take 2 times 4 root 3, which is 8 root 3. So these would be your approximate and exact answers for y. Let's try a couple more. So on part B, you can see we have the hypotenuse. The hypotenuse is always double the short leg. So if this is a 30, 60, 90 triangle, our 30-degree angle is up here. The short leg is across from that. So to get x, we're just going to take the hypotenuse and divide it by 2 to work backwards. So x ends up being 5. We don't have to go any further than that because that is the approximate and the exact answer. Now, once we know x is 5, to get y, we just take that short leg and we multiply by root 3. 5 root 3 would be the exact answer. We can also type that into our calculator and get an approximate answer, which is 8.66 for y. And last but not least, let's do part C. You can see here that we have another 30, 60, 90 triangle. This is our short leg over here. Remember, to get the hypotenuse, what we're going to do, let's call this hypotenuse. To get that, we just double the short leg. So maybe I want to call the hypotenuse x, okay? So to get x, we're going to double the 2 root 3. So we wind up with 4 root 3 is the exact answer, or that's approximately 6.93. So that's the hypotenuse. And let's just call this long leg y. So to remember, to get the long leg, we take that 2 root 3 side, that short leg, and we have to multiply by root 3. Now, root 3 times root 3, remember, is root 9, or think of it as just 3. And 2 times 3 is 6. There we have it. Your homework for tonight is the 8.3 homework. Don't forget to get that syllabus signed if you haven't already, and we'll see you tomorrow.